Hello and welcome to DCTP.tv from the Chaos Communication Congress in Hamburg. My next guest is Sergeij from Moscow, and he's part of the SCADA-Strangelove Hacker-Kollektiv, I would say. Hello, welcome, Sergeij.
Hi, everybody.
You talked about SCADA, and most of the viewers don't know SCADA, and but I ask you to come into our show because it's a very important and, as you showed and many others showed already, very vulnerable system which is responsible for large parts of our industry, controlling large parts of our industry, factories, etc. So just explain a little bit what SCADA means. Why is it important?
Yeah, SCADA, or correctly industrial control system, because SCADA is only part of industrial control system. It's things which make modern civilization working, because at moment a lot of things controlled by computer. It's a power plants, it's a transportation system like railways, it's things which you meet every single day. For instance, lights on the railroad in modern megapolises, in modern cities, controlled by a centralized computer system. But from security perspective, this system was built with focus on its functionality, not on security. It should work at least, yes. If it's work, don't touch it. But now most of the city systems become connected to large network, connected to internet. For instance, if you see a board on the train station with the
next train is going.
You can see it online, yes. But all this information coming from the field, devices, from the trains, from the special detectors which understand where train at this moment. Of course, it's coming via several networks to be translated to the internet. But anyway, if you connect something to internet, sometimes internet can connect back.
Okay.
So work become more and more complex. Industrial control system become more and more interconnected, and this create problem, because if it disconnected from internet, from big network, it's okay. But if you connect it to big network, you get all threats you have in the internet. You have worms, you have hackers, you have military guys.
Let's talk
and so on.
Before we talk about the vulnerabilities and what you can do with it, since all these systems are connected to the internet. Let's just illustrate a little bit more in detail where they appear, what they do. And so you said these systems were designed many years ago and not made for internet connection. Yep. So they were designed, they were working, they're pretty old. We have a small video here where you set up a model railway
Let's do that anywhere.
To demonstrate how SCADA and industrial systems work. So talk a little bit about it.
It's a kind of test bed we built for, demonstrate of vulnerabilities of industrial control system. This is toy railroad, but it's controlled by real world SCADA, which you can find on railroad, on nuclear plant, and so on.
Where is SCADA here?
Here it is on the screens. You can see because in most cases SCADA is just software for Windows, which controls special devices. You can see it here, with gray boxes. It's PLC, programming logical controllers.
So what does it mean? So these PLCs, these programmable logical controllers, are small What, computers?
It's small real-time computers which most important task of this computer is to switch relays according to the program.
Okay, say, for example, in the railroad or in a power station, you would have a small device that says, well, turn the turbine
Yep.
up,
Yep.
up,
Down. Yep.
down, temperature, up, down, or the velocity of the centrifuge, up, or down to a certain level.
Yeah, sometimes things more complex. For instance, if you control modern engine, you should not only control the level of power, but you also should shape this power according to special frequency and so on. But general idea the same.
Okay, so you have in a factory, you have these PLCs
Yep.
everywhere, and they are connected via a network.
Yep.
And they are controlled by this Windows
by
by
SCADA,
SCADA, by the
yeah.
Windows application you have on your monitor, and you can drag and drop or type in numbers to control all the devices in your factory.
Yeah. And on next level, SCADA system connect to MES system and to ERP system, like SAP NetWeaver, so business people can see how the process going, how many, for instance, I don't know, power you generate, and so on.
Okay. So, and how widespread are these systems?
It's near everywhere. Now we have in the world modern and very popular approach. It's smart grid. For instance, you can have your home at village, and you can install solar power generation on your roof.
Yeah.
And in most cases, this device will be controlled by little SCADA system. It's called smart grid network, which connected to all network of smart grid devices, and it controls how much energy you generated, at what time you should switch from the solar energy to external energy source, and so on. And now, in most cases, these devices also connected to internet to give you ability to, I don't know, control via iPhone application your process. And of course, it's widespread in industry. On
Car manufactured use it.
Yes. Every modern factory have it. Nuclear plants, power plants.
And you say, well, these systems are so vulnerable that you can control them remotely, that you can take them over?
From security perspective, if we can compare SCADA system with IT system, the level of maturity is similar we have in IT world 10 years ago. For instance, maybe you know about code red worm. It was in 2001 or 2002, and it infected internet services all around the world, Microsoft Internet Information Server. And after this infection, most of software developers decide, okay, guys, we should think about security. For industry control system, this situation was in 2010. It was Stuxnet worm, which in fact some industrial control system in Iran and in different countries. And only in 2010 people start thinking about security of industry control system.
Due to Stuxnet, because we have to talk a little bit about Stuxnet to remind people it was a very, very sophisticated attack on a nuclear plant or on other nuclear plants in Iran. They used several security holes in Windows and other applications, but in the end, Stuxnet was targeted to manipulate the SCADA system of a nuclear plant.
Not nuclear plant, centrifuge.
centrifuge.
Yeah, centrifuge. Yeah.
Explain shortly to remind us what Stuxnet did and how it used SCADA.
It's spreading via several vectors. One vector it's infected project file of SCADA, because in general SCADA it's like integrated development environment, like Microsoft Visual Studio. You can create special program for your plant. So from the box it does not work. You should describe your technological process.
Okay, we have this centrifuge and this centrifuge, and we have this power and just connect it, and so you build your own program for your for controlling your plant.
Yeah, absolutely. So Stuxnet infects project. Also, it's used zero-day vulnerability in Windows auto-run and to spread via USB sticks, and this is the way how malware can jump through air gap. So if you have if your network disconnected from internet, your for instance contractors who work with you can bring his laptop infected with malware, can bring USB flash and infect your network.
So just to say, well, we have SCADA and it's perfectly fine because it's not connected to the internet, is not the answer, because people come in with USB sticks, with other laptops and systems, and they jump the air gap. So
and not only people, the serious issue is operators, because we sit in working with these boring computers, and we need, for instance, to download something from internet for child. We connect mobile computers, we connect mobile phones to SCADA system to get internet access, and we download in different stuff, including malware, including pirated software, which very common have viruses inside. It's very common situation, and we meet it during our security assessment.
Okay, so and what did Stuxnet do to the facility?
After infection, it trying to find system which control centrifuge, and different version of Stuxnet use different vectors of attack. One of the vector was to manipulate speed of centrifuge or engine of the centrifuge, because it's rotate very quickly.
So and centrifuge were used to enrich the uranium. So they had to have a certain speed. To enrich the uranium. And Stuxnet manipulated
manipulate speed to create some kind of spikes on physical level, and to destroy it. So
and it basically worked, I think, right?
Yes, it's nobody can confirm or not confirm, but guys from Natanz say that we need to buy more than 1,000 centrifuges because some technical problems.
So that's basically points to the success, if you want, of Stuxnet. Okay, this was the first time.
Not first time,
but really first time that the attention was drawn to SCADA network. That people saw, well, our factories and everything is more or less run and controlled by these systems, and they're pretty vulnerable, actually. So what did you find out about what else is there? What kind of SCADA systems are there in the world? How do you find them, and how vulnerable are they?
Main problem of IC security is not targeted attack. Of course, if a big state decide to attack our state, it will find resources, it will write a very sophisticated malware and mount very sophisticated attack. But in most cases, during our assessment, we can find that for instance, on power plant, there is already some all the worm in network. And if this worm does not reduce performance, nobody care about it. So
nobody detected it because
yeah, it's
was working.
And working. Sometimes we know, okay, our antiviruses sometimes say, okay, you have a worm, not a problem.
Because it's working.
It's working, yeah.
And what does this worm do?
What it's you know, it's common internet worms. It's old stuff and common worms, but sometimes these worms can decrease performance. For instance, it can connect flat network and PLC goes down, and this is a problem. Not special worm, just common you can find in internet and so on. So.
And what kind of facilities did you find these worms?
It's not something special. What I'm trying to say, it's a common situation. So we provided more than 10 security assessment of ICS system per year, and every single time we can find that malware already here, or operators connect with HMI, it's human-machine interface, yes, to the internet, or other ways to abuse. So yeah, and you know, in most cases SCADA network can be hacked by script kiddie. You know who script kiddie? It's a guy who just download tools from the internet and can run it
locally,
and don't understand how it's work, just running stuff.
And what happens then? What can they do?
It's dependent on on your targets. If you have special targets, you can, for instance, make some money by fraud. It was a funny situation during, you know, gas station. When you buying gasoline for your car, gas station. There are a lot of, in most cases, all gas stations are automated. So when you pay in, you can see how many liters. Yeah. And people who work on gas station sometimes abuse it. They hack this automation to reduce amount of benzene you can buy to
get
change
it themselves and then sell it outside.
Yeah. So this is a simple way, because it's a little SCADA network,
on the gas station?
And it was on the same principles. If simple situation, you can break process, manufacturing process, for instance. You can stop it, and sometimes it can be very expensive to repair. For instance, if you have a process like you know, creating of plastics or so on, some chemical process, because it's very easy to stop and very hard to start again, because if
material cools down, it gets stuck and blocks all the pipes and everything.
Yeah. So it's can be a problem. It's not necessary problem which you know, it's not necessary threat which acting by human. Sometimes it's technical problem, but anyway, it's problem. If your SCADA networks go down, you have this problem. You need to spend.
And has it really happened? Do you know of cases where SCADA networks, apart from Stuxnet, were attacked and damage was done?
You know, people don't like public talk about it in most cases, but from public cases, there is very interesting situation in not interesting, very bad, but in US, when a public known worm in SCADA network create a big blackout in New York area. So it starts to spread in network and just overload by flooding traffic, and network goes down and blackout start to spreading through.
Due to infecting the SCADA system.
Yeah, but with not special, not cyber weapon.
Not a targeted attack. It was just a worm because security holes are there and worms spread and SCADA systems got infected. And is it proven or is it just a theory? Is it proven that this was the cause for the blackout?
Yep. Yeah. Also, a situation with Saudi Aramco. It's was internal attack when one of employees create special malware which erase all data on more than 30,000 of computers in this network, and all logistic process stopped. They still get oil, but they cannot sell it because all information about logistic was destroyed for several days.
Okay.
So
say you call yourself a white hat hacker. That means you analyze systems, you find vulnerabilities, and you do what with them?
We work with vendors. So for last 2 years, we found more than 150 vulnerabilities in different systems by Siemens, ABB, Emerson, and other. And we collaborate with vendors. We say, guys, here's a problem. Here's how to fix. And vendors, sometimes quick, sometimes not so quick, provide fixes, and we check how they fix the problem, and after this they publish it and say, customers, please update your system because you can have a problem.
We talk about the measures to protect the systems in a second, but say you were a black hat and you said, well, I don't know, I'd like to target the factory, Siemens power plant. Could you do it? Could you bring down any power plant, any factory?
It's ethical question. Of course, a hacker, or as any professional, it's a man with the rifle. So we have tools, we have knowledge, but how you will use this knowledge depending on your ethic.
But technically,
not a problem at all.
Why isn't it done more often?
It's nobody need it at moment. So if we talking about cyber criminals, they focus it on the revenue.
But they can blackmail a factory. So say, well, we could bring down your factory. You know it. SCADA vulnerabilities. Pay, I don't know, $1 million.
Yeah, maybe, but now we're happy by banking fraud and generate revenue from this side, and maybe it's the next stage. I don't know, but I hope no. But because here's one important point, because for instance, from security perspective, from if I am black hat, let's imagine if you have a if you're making some kind of banking fraud, you work with banks and maybe with police. If you're trying to work with industry system, with people safety, you will work with special services. Because in most cases it's critical industry infrastructure and is controlled by secret services.
So
it's
the
different.
Risk is
it's different people.
Okay, that's the one theory.
Maybe, yeah.
And let's say, okay, you said, well, the public awareness was drawn to SCADA in 2010. You, I don't know, you work together with vendors of SCADA systems. You confront them and you inform them about vulnerabilities you find. You said, well, sometimes they react rather quickly, other times they react rather slowly. Do you see any advancement? Is it getting more secure, these systems?
Yes, we see that things changing, but not so quickly. I think we need to maybe 5 years to change the situation dramatically, because of course vendors, many big vendors started to rethink in the situation. They organize special team like computer emergency response team inside the company, started to work with the team like us, and so on and so on. But this is a part of the problem. Next party of the who can help in this situation is the governments, and the governments also start thinking about it to create special law about critical infrastructure and so on and so on. But in most cases, if governments say, okay guys, you should protect your critical infrastructure, business who own SCADA system and operates it say, okay guys, but this is cost for me. Who will sponsor this security? And here's a challenge. In some countries, governments say, okay, we can
help with some money.
In directly or indirectly via fees or something. In some situation, government don't help, and this does not work because, and you know, and to make this to solve this problem, vendors, government, business, and industry, security industry, I mean, should work together. Because without collaboration, things will not change.
And how hard is it? I say, well, you have a factory built, I don't know, 10, 15 years ago. Well, you say, well, we have a huge factory, I don't know, 1,000, 2,000, 5,000 people working there, and everything is SCADA, and we have millions of parts and software. How hard is it to fix it?
So sometimes it's impossible to fix it. Sometimes
you have to remove everything.
It's easy to rebuild, and sometimes the best way is to disconnect it from everything and you know, install special patch man with the rifle on the enter. Sometimes you can fix things, you can update system, install additional security features, but all depend on the this system, because all system build it for this plant, for this technological process. And sometimes people even don't understand how it's working. They say, okay, we have 3 computers here, and also 10 on the
in the backyard.
On backyard, and we just if it fails, we just replace it. But we don't know how it's working. We bought it 10 years ago.
So someone else built it, no documentation. We know we press the button and the turbine turns, so it's working. Everything is fine. But you cannot change it. You have no plans.
So and if you don't know how it's working, you cannot protect it.
Okay. Okay, Sergej, thank you very much.
Thank you.
Your SCADA Strangelove information you find scadasl.org, right?
Yep.
SCADA Strangelove. And your talk is also on YouTube, I would assume. Your talk from the Chaos Communication Congress.
I hope it will be.
It was yesterday evening, so maybe it takes some more hours. But if you check out on YouTube, SCADA Strangelove Part 2. Already, right? Part 2, Part 1 was last year. So, okay, both check them out. Thanks for watching. My name is Philip Banse. Thanks for watching dctp.tv. You'll find the videos, this video and other videos on dctp.tv and on the YouTube channel of dctp.tv. Thank you very much. Stay tuned. Bye.
Bye.